Hi, I'm Fuzzy Manners, and today I'm going to be talking to you about Arduino. If you're already familiar with an Arduino, this may not be for you as it's aimed at complete beginners, but feel free to stick around, there's always more to learn and be refreshed on. So without further ado, let's dive right in. For whatever reason you want to get into Arduino programming, it's always a good idea to see what you can achieve first. So, let's look at some examples of things you can do at home with an Arduino and some electrical components.
Ha! Arduino Nano! We're gonna use this to mix the RGB channels to get the colors that we want. See, now you know and I know that that is Sauron's emission. Oh, that doesn't sound right.
The holidays coming up, I thought I'd give you a very simple yet interesting Arduino project, which is going to be helping you stay away from your house without worrying about your potted plants.
When the robot starts to tip over, the motors will move the lower part of the robot a little bit faster in the same direction. As a result, the lower part is forced back under the higher part of the robot.
The LED driver circuit only consists of an Arduino Nano, nothing else. And with the help of complementary parts, this project is more like a big soldering practice.
An Arduino board, in this case an Arduino Leonardo, is just a microcontroller with easy access to input and output pins and a way to flash the code onto the board. So, let's look at how to flash the code on it in the first place. You'll need to download a piece of software called Arduino IDE, which can be downloaded from arduino.cc. They also have a web editor, but for the sake of demonstration and ease, we'll use the software. Once it's downloaded, plug in the Arduino and load up the software. The most common first Hello World example that people do is to try to blink an LED, so that's exactly what we're going to do, first using an example and then by ourselves. Most, if not all Arduinos have an LED soldered onto them that can be controlled by the user. This LED is usually connected to digital pin 13, but it depends on which board you have. We'll talk more about the digital pins in a moment, but first, let's get the LED blinking. With the Arduino plugged in and the IDE open, go to File, Examples, Basics, and click Blink. Now we need to make sure the IDE knows which board we're using. In my case, it's an Arduino Leonardo. We can go to Tools, Board, and select the correct one. The same with the port number. Once done, we can click the upload button and it should flash the code to the board. Don't worry about the code right now, we'll go over that in a second. If all goes well, the board should look like this with a blinking LED. 1 second on and 1 second off. If all doesn't go well, make sure you've got the correct board and selected the right port. Now, let's see what's actually happening here. The grayed out text that begins with double slashes means that it's a comment and it's just there to help the user understand what's going on with the code. The actual code begins at the void setup line. Void basically means it's a function, it does something, and can usually be called from elsewhere in the code. In the case of the Arduino IDE, it needs a minimum of a setup and a loop function to be able to compile and flash it to the board. The parentheses after it are there to hold arguments. That's pieces of information that we wish to use inside the function that are set from elsewhere in the code. In the case of setup, it's none, so the parentheses are empty. Then, the start of the function is set with a curly bracket. Everything included inside the function will be between an opening and closing curly bracket. The next part starts with pin mode. This is a built-in function of the Arduino IDE that refers to the pins on the board. Do you want it as an input, like a button or a sensor of some sort? Or do you want it to output a signal, say to a screen or an LED for example? In the C or C++ programming language, which is what the Arduino IDE uses, when a line of code is finished, it's signified by a semicolon. The first part, after the open parenthesis, is the pin in which you're wanting to set the mode of. In this case, it's also built in and is named LED_built-in. The next part is whether you want it to be an input or an output. It's an LED, so it will be an output. Now the chip on the Arduino knows which pin we want, and that we want it to be an output pin. Next up is the loop section. This function runs continuously until it's either interrupted or the device loses power. The first thing we see in the loop function is digital write, which basically tells the pin that we want it to do something. More often than not we want it to go high or low, which is to go to voltage level or to be at ground level, or on and off if you will. In this case the digital write line has two arguments of LED built in, which tells the Arduino chip which pin you're referring to, and high, which means to set the pin to voltage level, or on. After this we see something called delay, which does exactly that. It delays the code, stopping everything for a set amount of time before carrying on. The time in a delay is measured in milliseconds, so here it's 1000 milliseconds, or 1 second. The next two lines are the same, apart from digital write has the pin set to low, which is ground level, or off in this case. So to sum it all up, when the Arduino is powered up, it sets the pins to an output, and then turns the pin high and low, with a second pause between each time, continuously until the power is turned off. Now let's do the same thing ourselves on a different Arduino pin, using an external LED instead of the built-in one. I'll use digital pin 4 as an example. You can refer to the board itself for the pin numbers. First I connect an LED to Arduino's pin 4 and ground through a 330 ohm resistor. This makes sure not to drive the LED with too much current and therefore have it stop working or have a shorter life. Now we can create a new sketch in the Arduino IDE from File, New. Now we have a fresh slate to write some code. In this example I want the LED to be on for half a second and then off for 2 seconds. Underneath the comment line that says put your setup code here to run once, we're going to type pin mode 4 output. And now in the loop section underneath the comment we can put digital write 4 high. On the next line delay 500 and then digital write 4 low. On the line after delay 2000. Once again making sure the board is selected, it will tell you in the bottom right corner of the window. We can upload the code and see if it worked. Success! If yours doesn't work, check the polarity of the LED, the longer leg to pin 4 and the shorter to ground, or try a different resistor and double check the code. One last thing that I feel is important to know this early on is the basic variable. If we go back to the code we can see where we have pin mode 4 output. What if we wanted it 5 instead? Sure we could just go and change all the 4s to 5s, but then what if we changed some ones again and wanted it on pin 6? It'd get a bit annoying, especially if the code is long. This is where the variable comes in. We can initialize and declare a variable before the setup like so. Int LED pin equals 4. Then everywhere we currently have 4 in reference to the pin number, we can just put LED pin, like so. Now, if we want to change it to pin 5 instead, we just change the LED pin variable at the top. Give it a go and try the LED in another digital pin. Be advised of using this for an analog pin though, as you'll have to use int LED pin equals A0, for example, to reference analog pin 0 on the board. I hope that helps some of you get a start in Arduino and Arduino IDE. If you created something cool, let me know in the comments. I'd love to have a look. If you've got any issues, post them there also. If you like this video, give it a like. If you don't, please tell me why. And please subscribe to FuzzyTek, press the bell, and until next time, bye bye. With pin headers and a programming port. That's the power supply. It's just a microcontroller with easy access to input and output pins. Controller with easy access to input and output pins, and a way to flash. To be able to flash the code. Also, an easy way to flash code onto the board via USB or some other serial. Let's do another video.